Hi, everybody. Here's question 79 from chapter 5. This question here asks for a percent yield of a reaction. And the reaction is as follows. We react methane with water. These are all in the gaseous state to form carbon monoxide and 3 moles of hydrogen. Okay, so we're given enough info to calculate moles of all of these things by the ideal gas law, and then not of carbon monoxide, but we're given hydrogen. We only need one of the products here. And then we're asked for the percent yield. We'll do that with the molar values after. So this is just a whole bunch of unit conversions, after which you guys are going to be pros at flipping torr, millimeters of mercury, into kilopascals, unless you're using the other R values. All right, so here we go. This is 732 torr. Right, we get 100 kilopascals for every 750.06. That's the conversion factor for that. This is times 25.5 liters, all divided by 8.314 joules on mole Kelvin. There's a mole in there somewhere. Times 298.15 Kelvin. So we're going to cancel the kelvins. Joule cancels with kilopascal liters. All right, millimeters of mercury cancel with each other. All right, and we should be left with moles, which we are. All right, so this equals 1.0039. All right, same process for the rest of these things, same conversion factors, same everything. So I'm going to skip the fun stuff here. This gives us 0.64464 moles. The same way, moles of H2. This one here is at STP, so you got to remember a bar at 0 degrees Celsius and such like that. 1.1537 moles. Now remember, this was a 3-to-1 molar ratio, meaning that we have to keep that in mind when we're calculating the theoretical. So we could see that water is our limiting reactant in this case. So we have definitely have less. We definitely have less than this. Remember, all you need is this doesn't need to consume the whole thing. Just whatever you have less of is going to be your limiting reactant. So there's a limiting reactant. So that means our theoretical yield is going to be 3 times whatever we got of this, because this is 3 times the stoichiometry of the water. All right. So the theoretical yield. I got to look at the question. I don't remember if we were asked for a theoretical. We're not asked for theoretical, just the percent yield. Okay, so we'll just calculate both of them at the same time then. Sorry about that. So we can do actual over theoretical. In this case, the actual is the amount of moles of hydrogen that we got. Right? Moles divided by the amount that we should have gotten theoretically. And again, that's 3 times our limiting reactant here. So we multiply 0.64464 moles. Cancel the moles. Multiply that by 100. And that gives us a percent yield of 59.7%. All right, there you go.